Look at this dual function fraction. When students see two completely different functional conditions, like we have fx and gx over here, inside a fractional sigma sum, which is equal to 19607, they immediately assume they will have to deal with complex algebraic combination. Would you believe me if I say that's a total illusion? Here the numerator follows a standard pattern and the denominator gx is hiding an elite visual trick that turns this monster into a standard 11th grade algebra. Don't believe me? So let's think sharp.
Hey thinkers, welcome back to Think Sharp Alley, where every turn leads to a smart solution.
We have been given the two conditions of two functions, fx plus y equal to fx fy with f1 equal to 7 and gx plus y equal to gxy with g1 equals to 1. First step is to decode the function fx. Now remember the functional equation which is given fx plus y equal to fx fy, that represents a standard exponential function model. But we can also derive it from here. Let's say we take simple values of x and y. Say x equal to 1 and y equal to 1. So putting the values in the given condition, we have f1 plus 1 is equal to f1 into f1. But we already have been given f1 is 7. So in the RHS part, I'll get 7 into 7. So we get f2 is equal to 7 squared. Let's see with a different value where we take x equal to 2 and y equal to 1. So putting the values in the condition, we get f2 plus 1, which is equal to f2 into f1. Now f2 we have got to be 7 squared and f1 is 7. So f3 becomes 7 cubed. So by induction, for any natural number x, fx will be 7 to the power x. Step 2. Let's decode the function gx. We have to analyze the highly unusual condition over here. Gx plus y is equal to gxy. Now to find the value of gx for any natural number, let's substitute simple inputs. X equal to 1 and y equal to 1. So we get g1 plus 1 is equal to g1 into 1, because that is what given to us, gx plus y equal to gxy, so which is equal to g1, and g1 is equal to 1, which means we get g2 is equal to 1. Now since g1 is 1 and g2 is also 1, so let us see for another value, x equal to 2, y equal to 1, so we get g2 plus 1 is equal to g2. And g2 is 1, so we get g3 as 1 as well. Now you can try out for different values as well, and you will see for that also we will get the value of the function as 1. Why? Because our starting point is g1, which is equal to 1. So the function outputs 1 for every single natural number input. So which means gx is equal to 1 for all natural number x. Now comes the step 3. Let's simplify and solve the summation. We have fx equal to 7 to the power x and gx is equal to 1. So if I substitute the value of fx and gx directly into the given summation, we will get summation 7 to the power x. Now this is a clean geometric series, because summation 7 to the power x means 7 to the power 1 plus 7 to the power 2 plus 7 to the power 3, and it will go on till 7 to the power n. So using the GP sum formula, which is this, here the first term a is 7 and common ratio r is also 7. We get this is equal to the value of the summation, which is 19607. Now solving this a bit, we get this, and cancelling by 7 and then multiplying by 1, we get 16806, and 1 goes to the RHS and gets added, so we get this. Now we have to find the value of n. So let's compute the powers of 7. We have 7 to the power 1 as 7, 7 square as 49, 7 cube is 343, 7 to the power 4 is 2401, 7 to the power 5 is 16807. So n is equal to 5. So the correct choice for this question is option D, 5. Whenever a functional equation looks strange, test basic boundary values like y equal to 1, x equal to 1 to uncover the hidden constants. If you spotted the constant behavior of gx right away, drop a thunder in the comment section, subscribe to Think Sharp Alley, and let's dive into question 19 next.